Welcome to Module 3 in a series of lectures on how to identify glaucomatous damage on OCT scans. The topic for this module is how to use the one-page report that I described in Module 2 to both quickly diagnose and also to understand optic neuropathy, glaucomatous damage. So here's the one-page report, which I refer to as our lab report. And I want to emphasize again, this is not about a report. One could move this around, one could add information, but what it is about is a method or a process by which one can identify quickly glaucomatous damage. And so the outline for this lecture is I'm going to start with a case example and a little bit of a review, and then we'll go on from there. All right, I'm going to mention now, but we're going to go into this in considerable depth in one of the subsequent modules. But the common clinical paradigm, that is the most commonly used set of exams that you'll find around the world, is the clinician starts with a fundus photo or and/or exam, does a 24-2 or 30-2 visual field, a visual field with a 6-degree grid, and an OCT disc scan. So let me show you 3 slides that summarize those results from a particular patient. And I want you to think about whether this eye has glaucomatous damage, either definitely or probably, or does not have glaucomatous damage, either definitely or probably, or not, or if you're not sure at all. So we'll keep your votes to these 3 categories. So here's the fundus photo, stereo photos. Here's the visual field. There's a blow-up of the statistics, and here. And there's the OCT report. So I'll show it to you again. Fundus photo, visual field, OCT report. Okay, so how many? So think about whether you think this eye has glaucomatous damage or probably has glaucomatous damage, or whether it falls into the probable or definitely not glaucomatous damage, or you're not sure. When I showed this to a group of clinicians and showed them the 3 slides you just saw, 40% said definitely or probably glaucoma, and 60% fell into these categories. All right, so now let's take a look at this. When I show this to clinicians, many of them say it looks normal. Some say there may be something going on in the inferior temporal region. Here it depends on what you look at. If you're looking at these statistics and you're basing it on the Oates criteria of glaucoma hemifield test or pattern standard deviation, this would be normal, right? Normal. However, if you look at the pattern here, at least to me, this certainly suggests glaucomatous damage. And then here's the OCT that I showed you. And if you look at this, that's the total average thickness that most people look at is normal. The quadrant clock hours are normal. The retinal nerve fiber layer thickness is normal. You may or may not be worried about that. All right, now what do you think? Take a look at this report. Well, first of all, my eye is drawn to this right here. I mean, look at this. Somebody took a bite out of the retinal ganglia cells. It's significant. There's the probability plot in field view. There's a divot. There's a decrease there, but it doesn't go into the red region, so it's not showing up as a quadrant defect or a defect if you're just doing the traditional OCT disc analysis. But there it is. And here is a suggestion of a thin defect in the retinal nerve fiber layer on the probability map, again, up there in field view. Now, do you think this eye is probably normal? Well, after I showed the same group of clinicians this, so many of them changed their minds. So before, 40% said definitely or probably, after 80%, and before 60% fell into one of these three categories, after only 20% thought it was not glaucomatous or I'm not sure. Now, why 20%? Well, and how would we convince them that they might be wrong, or you might be wrong if you're in that category? Well, this gets me to principle number 5 from last lecture. Damage can be confirmed by topographically comparing 10-2 and 24-2 visual field data to the probability maps for retinal ganglion cell and retinal nerve fibrillata. This disease is a beautifully anatomical disease. So topographically, structure and function should agree, not just in metrics, but topographically. So let me show you what I mean. Here's the 10-2. That doesn't look so good here, does it? So if we take those points and outline the same points over here, you can see this abnormal region falls in the same region. This topographical agreement between the field and the OCT, and same with up here. You can see the agreement up here as well. All right. Now, so I ask you, anyone still think this is probably normal? Okay, so this gets me to the essence of what we're trying to do with this report and with our approach. Everything should fit. You want to be able to relate the different parts of this report to get a coherent view of what's going on. So let's do some exercises to try to build in an understanding of the topic of the way that these different displays should topographically agree. So I'm going to take this healthy eye, and I'm going to assume we give it glaucoma. So let's suppose that instead of being the normal range, it dips down here, and then we'd expect to see something on the disc on the circle scan here. So let's assume that this is thinned, right? So we got real retinal nerve fibrillata damage there. So then what should we expect happens to the ganglion cell thickness map, right? Should it appear like this? Well, no, not really, because after all, this is in the macular region here, this defect. So what about this? Should it look like this? Well, no, that doesn't look right, because this up here is in the lower retina, and this is in the upper retina. That can't be right. What about this? Oh, well, that looks pretty good, doesn't it? You know, this defect here should be in the macular, it should be at the edge of the macula, and it should be inferior retina. And sure enough, it is. Well, let's just take a look at D to be sure. Well, C or D? Well, C looks like glaucomatous damage. D looks like what you'd expect for a left eye, not a right eye. So the answer is C. Okay. Now, just to remind you, this is the model of the macula. So we can put the model of the macula on. This defect here is right there on the model, and it should be right there in the model. So you see everything fits. These are different measurements. This is a circle around the disc, and it's retinal nerve fibrillata. This is ganglion cells, and it's in the center of the retina. So if these two things agree, different scans, different analysis, then you're pretty confident you've got real damage. Okay. All right, now what should this look like? So this is a probability map that matches this, right? Well, does it look like that? Well, that looks pretty good, doesn't it? I mean, this is in retina view, that's in field view. Let's see what the other choices are. No, it can't be that, because this has to be flipped for field view. And it can't be that, because that's outside the macula. So it must be B. So this corresponds to this, corresponds to this. Remember, if this is the direction on the retina, this is the direction on the field. What about this? As is? Well, you'd hope you'd see something. What about this? Well, that's correct hemifield because this is lower disc, upper retina, so correct. But look, it's way outside the macula. This should be inside the macula. This circle is plus or minus 8 degrees. It's the same as that circle. What about this? Oh, that looks good, but let's just make sure it's not D. No, D's in the wrong hemifield. So the answer is C. Again, this, they all go together. Okay, so you want to understand the relationship among the various elements of the lab report. Right. Again, here, here, and here. So damage there, damage here, damage there, damage there, and there. All go together. Okay. Now let's go in the other direction. Assume that the retinal nerve fiber layer probability map looked like this. So suppose we started out with this, right? And what do we expect over here? That? Well, lower. Yeah, but this is inside the macula, isn't it? And this is not, so it shouldn't be that. What about this? Well, that's upper disc, and this is upper field, so that can't be right. This has to be something in this region here. What about this? Well, that's a better candidate, but you notice it's outside 15 degrees. So that would be, someplace up here. That'd be D, right? So let's look at D. Oops. Yep, that looks right. So lower disc, upper retina, and it's on the edge of the 15 degrees, and that's right about in the right place. It's outside the macula. That's in the right about the same place. Okay, so this, we'll put the model on top to confirm that. So what about this? And there, and there? Well, it should be fine because it's outside the macula. All right. Next example. Assume that the circumpapillary thickness map looked like this. So now let's put a defect here instead. Right? So here's the macula. Even though it's sort of like in the same place because the macula is offset, this is just on the edge of the macula. So what should we expect here? Well, this one, it should be something like this, right? It should be, if this is upper disc, it should be lower, and it should be right at the edge of the macula, just like that. So you should expect something like this on the plot, probability plot. And something like this on here. And something like this on there. And again, if we relate it back to the model, now we have damage right here, which is right on the edge of that, right? Which is not there, because that would correspond to that. Okay, so that's, finally, let's just look at some more examples to see if we can reinforce these points. So, is this normal? Well, we had 2 glaucoma specialists that said it was abnormal, and 2 others that thought it might be normal. So is it abnormal? Right? Oh, actually, no, I take it back. I showed this to 4 glaucoma specialists. They all said abnormal. Here's the visual field. That looks pretty good, doesn't it? Although there is low test reliability, but that's mainly just fixation. So I'm going to discount that. This looks like a normal field. So is this preclinical? Pre-parametric, rather? Well, no. Look at that. That's beautiful, right? Normal, normal, normal. The disc may look abnormal, but this eye does not have optic neuropathy. What about this? So this is the one that there was disagreement. 2 2 said it was glaucomatous. 2 said no, it was just a large cup, large disc. 2. All right, there's the OCT report. That looks normal. There's the visual field. I'd say most would say that's normal. And here's the glaucoma heavy field is borderline, but everything else looks great. Standard deviation is normal. Mean deviation is normal. Here's the OCT, however. This is an interesting one, because you have this. Excuse me, I had to turn off the sound on my computer. This looks like an abnormal defect here. That would correspond to where? That would correspond to right there. Whoa, okay. Right, so let's do that again. You've got this and that, right? Now where would that be? Up here? Well, it would be right about there. So it's not in the abnormal range, but you see this little dip? That's probably real, right? So how would we test the hypothesis that this is abnormal? Remember the 24-2 is abnormal, right? Well, let's take a look at the 10-2, right? These points here correspond to about there and there, right? So I'm not going to argue that I'm absolutely sure that this eye has glaucoma, but I'm worried if this were my eye, that there's damage to the macula here. Am I absolutely confident? No, but I certainly would want to be followed, or I would want to follow a patient with these characteristics with both a 10-2 and an OCT, not with a 24-2. It's just, there's always going to be ambiguous or cases that are suspect. I would put this in a very high suspect category. All right, here's another one. This one's easy, right? Oh, I'm sorry. This is the patient's other eye. Now that you see this, now you're really worried, right? Because now you know the other eye has glaucoma. Here's the 10-2 on the left here, right? And if I put the eye we were just looking at on top of this, that's what it would look like. So I think this eye started out life I think that it started out life somewhere up here, and the other eye is starting to go in the same direction that this is going in. So the point here is it can be useful to look at the other eye. All right, what about this eye? Well, you know, there's a disc hemorrhage here. You know, that's not good. And this is borderline here, and then this is a nasal step. Oh, so I mean, I think we're done, right? This patient looks like it's got early damage, and it's got a nasal step, right? So you may want to follow this in however you follow patients that have what looks like early damage. Right? That's the regions I was just talking about. Right, so early glaucoma followed with a 24-2, yes? Well, the answer is no, because although there's damage here, and you can see it's probably due to, you probably see this is probably the sign of this. That's damage here, right? That's at the edge of this 15-degree central, plus or minus 15 degrees. It's right about here, right? But you know, we can put the model on top. But this right here, right, corresponds to this right here, and that small spot there, and that small spot there. So this patient has much more than just a nasal step. This patient is down in this region across here, including this defect here that is marching towards fixation. Well, can we test that? I mean, that's right smack in our macular vulnerability zone. And here's the model. Can we test that? Well, here's the 10-2 for this patient. We circle these points. That's where it is on here. And that's where it is on here. I think we've nailed it. The concern here is not that nasal step. The concern here is the damage close to fixation. And you want to follow this patient with an OCT and a 10-2. So not simply a nasal step. The one-page report here will help you quickly diagnose and understand the damage. So I understand this damage now in a way that I couldn't based on the field or just these kinds of plots. There is damage in this entire region. This patient probably started out like this, and like you can see over here, and then this is all starting to go down, and you're seeing it manifest itself as a nasal step as well as a defect very close to fixation on the 10-2. All right, here's another patient. Family history, no family history of glaucoma, high IOP. Here's the OCT, clearly abnormal. Here's the visual field, also abnormal. So that defect there corresponds to this here. Now, but what is that? That almost looks like something a neuro-ophthalmologist would see. That looks like a maculopapillary defect, right? Why the maculopapillary damage? Well, again, this report not only helps you quickly diagnose it, but by looking at the relationship among the elements in this report, you can also understand the pattern of visual field defect. So this defect here maps onto here and is part of a defect that we're not seeing on the map here. That in the maculopapillary region is right there on the retinal nerve fiber layer, and if we circle, the same, and if we put the model on, you can see what's happening here. What's happening here is you're getting damage throughout this whole region. So this is the region that's in blue here. You can see it's down pretty much throughout this region. Let's blow it up. Look at the detail here, by the way. So that's the 24-2. That's the macular vulnerability zone, right? Which is over here on this plot. This is essentially fixation here. You can see this defect is approaching fixation. Right? If we put the macula model on, this is what you get. But let's take a look at the 10-2. You can see the 10-2 has this abnormal region here, which corresponds to this out here. And it has this abnormal region here, which corresponds to this region here. So this may look like two defects to you. It may look like part of a classic arcuate and then part of a maculopapillary. But again, you have damage in this region here, and this is your more typical region, and just in this case, the damage is extending much closer to fixation and including the maculopapillary bundle. All right, so finally, you should be able to go in both directions. So we've been predicting, in a sense, the visual field from the OCT. You should be able to do the reverse. So, suppose you had something that looked like this on the visual field. So you've got a nasal step or an extended nasal step on the 24-2. And then here's the 10-2, right? So these points here, this is 3 degrees, this is 9 degrees. So these points here fit into this region here. So you really have one continuous defect, and that's what's happening here. This is your continuous defect. Okay, so that's Module 3. I hope it's helped you understand. The message here is you want to take a look at this, and everything should fit before you make a diagnosis. Thank you, and I hope to see you again for Module 4.